Hey, what's going on, guys? We're back here with part 11, and one thing I remembered in the last, I was looking over one of a previous video on my phone just to see how everything looked when I uploaded it. Is that it's pretty small, so I'm gonna try and zoom in and hopefully keep it this way for the remainder of the tutorials. We left off with our player camera script. It's not completely done because we want to fine tune it later on, but until we get a game working, we're just gonna call it done for now. And now we want to get actual collision working um, with our objects. So the way we set this up using two character controllers is not really the best setup because our physics is limited between two character controllers. That's why usually I don't have my enemies as character controllers, and instead I have them as rigid bodies. But it's easier to set up this way for motion. So we're gonna go ahead and do a quick workaround. We're gonna implement our own physics engine, even though it's not really like a physics engine. What we'll do is well, we're gonna check the distance. What I was just thinking in my head, I forgot I did this off camera, but I'll go ahead and explain it now. So at the end of I remember we left off, and I said I was gonna tell the enemy to destroy itself if it got too far away, and I was just toying around with that. So what we did is we made a new check, and if the enemy is too far from the player, then we're going to destroy ourselves. And then obviously we made this new method called enemy too far from player. It's going to be of type bool, and it's return this value here. So let me explain this. So Vector3 Distance is a method that comes built into the Unity engine, and it takes the distance between one position and a second position, and it returns that value. And then if that value is greater than 20, it's going to return true, and if it's not, it'll return false. And obviously the two positions we put in is our position here and the player's position. And you'll notice player here is a new variable that we initialized up top here as a private game object. Now normally we keep these things public and we just drag on the player, but for an object such as an enemy where we're spawning him in at runtime, we don't really have access to the player. So what we have to do is make him private, and then at the startup we can do game object, find game object with tag, with the matching tag of player. Now one thing I want to keep in mind is that this method here is pretty resource extensive, and luckily it's only called on startup. But if this was something like a game manager where it has to keep track of the player, you wouldn't want this in an update function, because what this method has to do is go through all the game objects currently in your scene and check their tag. And if you're doing that every frame, it's a lot of wasted resources that you don't really need to be wasting. So that's what that does. I'm going to go ahead and just save it as it is and just show you guys what that looks like. Now before I do, let me explain something too. What I mean by tag is down here. If you underneath its name, you just click on it. Tag should be a default one already created. You can just hit save. And then one other thing I forgot to mention is edit project settings. You can add your tags in here, but also in our input, the input manager. Here's where, remember that jump button? It's one of the default configured ones, but if you wanted to add more buttons, here's how you would do it. You just add a button on the end here. You can give it a name, give it its button, what it does, and so that's that. So what we're gonna do now is move away, and now our cube, as soon as it gets far away, if you're watching over here where my mouse is, it's destroying itself as soon as it gets more than 20 units away. Now if we get in closer, like the sphere, it's going to stay in here, but the instant we jump over it and move away, you can watch, it just destroyed itself. Okay? So next thing I want to do is get our collision working. I'm just going to minimize these guys so he's not it's not obstructing our view here. We're going to do, actually open this back again. We're going to do check collision. Let's go ahead and make this function here. And what this will do is, and remember this is being called every frame, we'll do an if player dot transform dot position dot x minus our transform dot position dot x is less than or equal to our controller dot radius, and then we'll just put in these curly braces, we'll put collision. So what this does is it takes our the player's x position, that's its left and right value, minus its own x value, and what that does is it gets the difference between them. Basically, that's the distance from them. And the reason we didn't have to do a vector3 dot distance is because right now I'm just checking if its left and right axis is the same, and if it's less than the controller dot radius or equal to it, then that's how we know that we are touching the player. Now, one thing I want to keep in mind though is the player can jump, and so can we. So if we are, let's say the player's jumping above this enemy, we don't want to do collision. So what we want to do is like another if statement. So if player dot get component, remember this guy, character controller dot is grounded, a better way we'll do if not player is grounded. So remember that not operator I was talking about? I think that was like episode 1. This just returns the opposite of this. So if it's not grounded, and if a third one, player dot transform dot position dot y is greater than, we want to get our height. So one way you can do this is through collision. So we'll do our controller dot height, and we're just going to return. Now, like I said, this is a void, so we don't need any return value. We can just do return, and it'll exit this code. A better way of doing this is I think I'm going to start to implement compound. Well, no, we'll keep it like that. Okay, it looks messy to me. I don't know if it looks messy to you guys, but just because I'm used to programming a certain way, it looks messy. But it's fine. The functionality is the same, just readability that messes with me. So now we've got if the player is touching us and the player is not in the air above us, then it'll run this code. We will do player dot get component, I health dot do damage, and then we'll just pass in a 1. Okay, and then inside our generic health script, I just put a print statement receiver damage, so we can tell when we actually did get hit. So let's give it a go. Collision is always a rough one for me, so we'll go ahead and see. Let's cross our fingers. Oh my goodness! Wow. He killed us pretty fast, actually. Let me go over here. Okay. He's not even touching us. So what we have to do is let's figure out why this is. Okay, I have an idea. I know. Put parentheses around this guy because this is assuming that the player's x value is greater than our own x value, and if we are on the right side of him or the left side of him, it could be a negative value. So we want the mathf.abs. What that does is just a handy dandy math function that gets the absolute value of this. So if it's a negative, it'll just convert that to a positive version of it. Okay, that's just what that does. Okay, let's go ahead and touch him. Oh, okay. That's another thing I need to implement is only applying damage a certain amount of time, not once per frame. But for now, we'll leave it like this. Hold on a second. Okay, sorry, I can only record 10-minute clips. So next thing I want to do is if we're not grounded, so if we're in the air, and if our player's Y position is greater than the controller height, let's do the damage. Okay, so the reason why this is a little iffy is because if the enemy is moving away from us and we're moving in that same direction, even if we do touch it, it's getting so close, but it's not an exact value, so it might be like a tiny bit less than or greater than the radius. So what we can do is just add 0.1f here. And this is a good debugging practice. Normally for little things like this, I would pause the video, make sure I know what's going on here, and then let you guys know. But every once in a while I like to do a video like this where, you know, I can show myself doing something not right. So for some reason it's only doing damage when we are not grounded. So just for now, I'm going to just remove this entire thing. Oops. And now, whether or not we're grounded or not, we should be doing the damage. Okay, it's because our x value isn't that close. So instead of 0.1, we'll do what's a good threshold? Let me see. We'll do alright, we'll do 0.3. Okay, why not? 0.25. See, the larger we make this number, the easier it'll be to detect collision. However, the more unrealistic it is. So you need to find a happy medium between the two. And actually, before I hit play here, another good thing to keep in mind is debug. So we're going to go ahead and debug this. .toString is the distance. Okay, and then we're going to go ahead and print the controller.radius. ToString is the radius. Okay, so let's go ahead and actually, you know, I'm probably gonna have to do this where I disable my spawner for now because it's too many things to keep track of. So I'll put him over here. Okay, so that's the distance from us. 0.5 is the radius. When we're here, our distance, okay, I see now. So, if you don't know, what we're checking, if we go back into the script, is we're checking from the player's transform position and our transform position, which is the center point between these two. So, we're checking between the center point of the cube and the center point of the capsule. So, what we actually need is well, instead of the center point, we're gonna have to put in enough space for the player's own collider as well. So what we can do is go back in here, and we'll do our transform.position.x here, and then we'll do minus the player dot get component controller dot radius. Okay, Okay, there we go. And then I'm gonna go ahead and uncomment those guys. Oh my goodness. I accidentally hit the wrong button when I was commenting this, so it made everything undercase. Okay, this is a long video, but I think it's a good one. It's a good learning experience. Shoot, I wasn't paying attention. So you can kind of see how debug works. So I'm gonna attempt to jump over. Okay, no, my own game is beating me. Okay, I'm just gonna keep running it until it moves my direction. I'm gonna attempt to jump over him and see if I can do it. Can I jump? Alright, I'll have to make this perfect. Hold on, actually. Let's go ahead and make his jump speed a little higher. Oh yeah, that's plenty. So as you can see, I can... Okay, I didn't quite make it. But now I can jump over him. Our own built-in collision system is working. And I'll stop it here because it's been a rather long video. In the next video, we'll see if we can get about only doing the damage if it's been a certain amount of time.